So just a quick reminder, yesterday we wrote about, well, we started writing about interval notation. So remember, an interval means some kind of range of values. It could be infinite, like 10 to infinity, or it could be a closed interval, meaning like 10 to 10, 10 to 15 or something. We will always start with the smaller number on the left side of our interval, and then things are separated by a comma inside. So it goes small number, big number, smaller number, bigger number. We use brackets if it's also equal to the number, parentheses if it's not equal, which would be open circle, and then infinities will always use parentheses. So I want to add to this because we ran out of time yesterday. So find these. If you're struggling to find your notes, please let me help you take better notes, okay? My goal is for you to organize your notes as I am up here. So if I don't write it in here, then put it in your notebook elsewhere. If I do write it up here, do your best to copy what I write so that you have good notes to use on assessments. Okay. Out to the side of this, I want you to say, just remind yourself this is for closed circle. So brackets go with closed circle. And then not equal to, change color there. That goes with open circles. So parentheses open, brackets closed. Hopefully that keeps things straight. Okay. Interval structure, let's call it that. So structure. Smaller number of the interval, comma, don't lose the comma, larger number on the interval. Okay, and I'm using parentheses, it could be brackets, it could be a mixture. In fact, let's even remind you that it's okay to mix brackets and parentheses. Alright, I'll pause and let you catch up. That's what I'm going to do right in this next box, because we don't really need to go to our main example boxes towards the back of your packet. This stuff is not like, it doesn't take a ton of space. So let's do x greater than 5. What is the interval notation for that? Well, it starts at 5, doesn't it? Maybe we should even do the picture. Maybe that would help. So 5, this is open circle pointing right. And then our interval starts at 5. Is it parenthesis or bracket? Excuse me, parenthesis or bracket on the 5? Parenthesis, because it's not equal to. Starts at 5, that's the lower number. What's the bigger number? Infinity, which isn't really a number. And then that has a parenthesis because infinities always do. Okay? Alright, next one. Also, notice that intervals do not have any letters in there. Okay? It's just numbers or infinity. Yeah, let's just do this one next. Graph. Figure 6. What does this one look like?
Minus infinity.
Okay, we'll do that next. So closed circle, which way does the arrow point? Left, because it's all values less than 6. And then parenthesis negative infinity, because here's the thing. Everybody pause your writing and look here. No. Unless your name is Abby. Do you guys agree that it looks like we start here and go left? So that's what tempts students to write 6 to negative. Don't write this. Tempts students to write this. What's wrong with that? That is 100% wrong for two reasons, but like, give me one of them.
Bracket.
Bracket's okay on the 6, because it is a closed circle on 6.
Wait.
Yeah, can negative infinity ever be the bigger number?
No.
No, that doesn't make sense. Okay. And then the other reason is because it's going the wrong way, technically. So, let's get it. Make sure you're reading correctly. We're always reading left to right. Always read left to right. I think that's a good little reminder. Caution right here. Caution. Always read left to right. Okay, let's do one like your packet from last night. X not equal to 7. This is a good one. Please make sure you understand it. If you don't, stop me in this, because this will test if you understand what the symbols are showing. Okay? So, the inequality notation here just says everything except 7. So we have infinitely many numbers, but not 7. How do we show this on the number line? We did one like this yesterday.
7 and then both ways.
Yep, open circle on the 7 and then arrow both ways. Open circle because it cannot be 7, and then everything else is fine. So in terms of our interval, this one's kind of tricky. Okay, I'm hearing it. Negative infinity to
7.
Okay, so we're going to go all the way to 7, but this parenthesis tells us not 7. Okay, so get as close as you want, but never get to 7.
And then 7 to infinity.
Okay, and if you're writing this, which you should do, leave a little gap in between these. Here's what Jeremiah said. He said 7 to infinity, and parentheses on everything, because it can't be infinity and it can't be 7. Okay? And I told you to leave a little gap because this is two pieces of our interval, and we have to tie them together with this symbol, which looks like a U, but don't make it a U. It's like a U, but not one. And it stands for the union, and you can read this in math like or. So it's negative infinity to 7 or 7 to infinity. But use that little union symbol in there when you're combining interval pieces or parts. Okay? Alright, so there's some examples on how to use this. It's totally fine to mix and match parentheses and brackets if necessary. So that said, let's go check here first, and then we'll check or finish the last two problems from the other day. Do you need more time? You're good? Alright. X less than or equal to negative 3 is negative infinity to 3 parenthesis bracket. Parenthesis bracket. You guys do have this. No, you don't. Never mind. I took this page off. Okay, graph closed circle left on 3. Quick reminder. Does the arrow always follow the inequality symbol? No. Always read from the variable. For example, this one says negative infinity up to 4. So I could write it this way. X is less than 4. But I'm writing it weird. On purpose, I'm writing it weird. How do I know there's no or equal to here?
Because it's both parentheses.
Yep. Open circle left on the 4. Okay, next one. This, I know you probably can't see, but it's a 2. I can make that bigger. So it's closed circle on the 2 and closed circle on the 6. So that's nice. That's actually easier, I think. Let's do interval first. Closed circle on the 2 up to 6. Closed circle on the 6. So bracket, bracket. How'd you do on that one? If you got to it. Okay. Now the inequality for this is kind of different. So we have the 2 less than or equal to x less than or equal to 6. That's called a compound inequality when it goes both directions. Okay? I will give you this piece of advice, or warning maybe. When you write a compound inequality, your inequalities will always point left. Don't mix and match them. They always point left. You just have to decide if it's or equal to, and also which order they go in. 5 to infinity, this would be x greater than or equal to 5. So bracket greater than or equal to 5, closed circle, pointing to the right. How's this going? We probably are getting where most people haven't gotten to yet. Feel like it's going okay? Okay, I'll do one more with you. So this is 1, and it's just pointing left forever. So this is negative infinity. Remember, we're reading, even though the arrow points to the left, we are reading to the right. So negative infinity up to 1 with the bracket. And then our interval x is less than or equal to 1. Okay, why don't you try 2 more? Try 7, 6, do 6, 7, or 9. I'm going to zoom it back, but 6, 7, and 9, I should have said. Alright, x is less than 1, or x is greater than or equal to 5. So we have everything to the left of 1, which is negative infinity up to 1, parenthesis, because it's not or equal to. And then starting at 5 and going to infinity, except for this needs to be a bracket, because it's also or equal to. And then stick your little union symbol in between. How'd you do on that interval? Okay. Well, you saw me just about do that too. Alright, so 1 open circle left, 5 closed circle right for our picture. Okay, next one. This is 5, I'll negative 5, and this is negative 1. So parentheses, because these are both open circles, negative 5 up to negative 1, parentheses again. Okay, and then like I said, my suggestion for doing the compound inequalities is put x and then put your 2 inequalities right there and always point them left, and then just fill in your numbers so it goes negative 5 to negative 1. Don't mix and match them. Alright, and then I asked you to do 9, so this is negative 1 and this is positive 2. So we are negative infinity, remember we're reading left to right, negative infinity to negative 1, bracket there, and then 2 to infinity, parentheses on both, union in the middle. And this is going to require 2 inequalities, so x is less than or equal to negative 1. And x is greater than 2. How'd you do? So actually, I do want you to be specific. You had to fill 2 things in on each one. So there were 6 possible correct answers. Go ahead and hold up how many you got correct. So 2 for each one. Hold up how many you got correct. Well, and then I don't know, did everybody have a chance to do all 6? Can you do? Okay, so this is important. If you got 3 and you only did 3, like 3 out of 3, show me that, because that's not the same as 3 out of 6. Okay? So show me how many you got out of the total that you did. So give me 2. Like think of when I write on your paper, 3 out of 3 or 3 out of 4 or whatever. Are you gonna do it? How many did you get? See, that looks a little better. You didn't ever tell me that. Okay. Those of you who did last night's work, here's the rest of those. You were just filling out the intervals for, looks like 4, 5, and 4, 5 through the end. Okay, so this one, interval is negative infinity to 38, bracket, and parenthesis. Infinity, bracket, parenthesis. This is like the one we put in your notes. Negative infinity to 0, parentheses, union 0 to infinity. Okay, and then last 2 to infinity, parentheses on both. So I can scroll so you can see all those again. There we go. Now, yesterday we didn't quite have a chance to talk through all this, so if those didn't go well, I get it. But at this point, hopefully it's getting better and you're kind of making sense of it. So we have 3 forms. I'm going to call in 3 people. You're going to tell me one of the forms that you haven't heard yet. Ready? We have 3 forms of our answers. What are they? Everybody understand what I'm asking? I'm going to point to you and you're going to tell me one of the forms that we have to write our answers in. One of the 3. Okay? If I say it, it will tell you, so let's just see how this goes. Arista, start us off. Give us one form. Okay, number line. So the graph on the number line, we call it. Okay? Now you have 2 more options, so if I point to you, don't say number line. Luis, give me another one. Well, 2 of them are shown there. Actually, all 3. Interval notation. Okay, so interval notation. 3rd one. Alright. Yeah, perfect. Inequality notation. Okay, if you look at your notes, do you see how we did all 3 each time?
Oh. Wait, that
Okay.
makes sense now.
Yep. So maybe on your notes, go title that of the 3 forms. So we have inequality notation. Then we have a graph on a number line. I'm going to change color there. Okay, and then we have interval. That's the last one on each one. So inequality, graph on a number line, and interval notation. Those are our 3 forms for showing our inequalities, our answers. Everybody good on that? Okay, yeah.
Can you go back to the last answer on the
Here. To infinity? Parentheses. I will tell you that my favorite is interval notation. I feel like it communicates a whole lot without writing a whole lot, which is nice. I really don't like the graphs that much. That's a personal preference. Intervals you'll use a lot as you go through in other math classes. Okay, now here's the question. I've been telling you that these are the 3 ways we show our answers. So how do we get answers to actually show these different methods? Okay, that's our next question. So just to remind you, listen carefully. In this class we started off with a review of order of operations. Then we did a review of simplifying, which was distributive property, combining like terms. Then we reviewed solving with just a variable on one side. Then we reviewed, and maybe learned new, solving with variables on 2 sides. And then we did all that with fractions in there and decimals. And that's kind of the big ideas we've hit so far. Solving, solving, solving. Okay? That's what we're going to do with inequalities. We just had to talk about how we show our answers with inequalities first. But now we're going to go back to solving, and how do we solve these things? That's a big deal. So here's an example of a very basic one. If this was an equation, you guys could all solve this, right? Pretty fast, I think. Based on your quiz results that I showed you yesterday, most of you could solve that. If it was an equation, you could solve it really quickly. What would we do first? Again, think of it as an equation for a second.
Minus 5.
Okay, we'll subtract our 5. We'll get 10. Now what? Divide by 2. And we'll get 5. Okay, and then this time we have this inequality in there instead. What does the inequality say in words?
X is greater than larger than 5.
Yeah, good. So greater than or equal to 5. And then here's the 3 forms that we'll do our answer in. So we already have our our inequality notation. It's okay to flip that around if you want. Let's do our graph. Is it open or closed? And pointing. Okay, and then interval, bracket or parenthesis.
Bracket.
5 going to infinity, parenthesis. Okay, there's our process. Solve and then write in the 3 forms. Solve and write in the 3 forms. Okay, did we do anything different here than we would have if it was an equation? No, it's the same. Have you guys done this before? Yay, we're finally doing something new. Oh, we did intervals, that was new too. Okay, here's the good news. Everybody listen, we can write this down in a second. Solving inequalities is virtually the same as equations, with the exception of one little twist. But otherwise, all the steps are the same. We want to work to get the variable by itself in a sort of just undo balance kind of way. So undo to get rid of 5, undo by dividing by 2, and get that variable by itself. But there is a twist. Let's see. Give me a second to go to this page. You guys flip to this page as well, please. And this is what it looks like. Yeah, it's in that very right basket over there. Okay, so look what happens. We're going to analyze what the twist is, and then you just have to be on the lookout for it. Otherwise, solve just like we have with equations. I mean, we're doing notes, but yeah, whenever, yeah. Okay, so look what happens. We're going to add, apply operations to 4. Do you guys, first of all, notice 4, yes, it's less than 6. That is true, right? Right? Okay, so this initial one is true. Okay, if we add 4, and we're talking about add 4 to both sides, it is 8 less than 10. Is that still true or false? That's still true. Okay, add negative 4. So now we're going to add to both sides, and we end up back at 4 and 6. That is still true. Okay, what if we subtract 10? Okay, so we get negative 6 and negative 4. That is still true. Multiply by 4. Times 4 times 4. Negative 24 and negative 16. Is that still true?
Yeah.
Divide by 2. Negative 12, negative 8. Is that still true? Okay, multiply by negative 3. What's negative 12 times negative 3? 36. Negative 8 times negative 3
False.
is positive 24. Is this true?
False.
False. What happened? Everything was going smoothly until we did what? Multiply. Well, we multiplied up here and it was still fine. By a negative. So why do you think that made a difference? Yeah, it is.
Because when it's a negative, it's based off what's closer to 0, and if you leave by a positive, it just gets bigger.
Okay. So we're flipping the sign, and it's referencing 0 is what we said. Okay. What if we divide by negative 2? Let's go do that. So divide by negative 2. What's 36 divided by negative 2? 24 divided by negative 2. Negative 12. So now we're back to true again. Interesting. So, do you see how we did two negative operations and it fixed it? Does everybody notice that? Okay. I want you to branch on your paper. Now, you're going to fill this in a second. Actually, we'll go put it on our notes. But let's branch off of this negative 12 and negative 8. And let's, instead of multiplying by negative 3, let's divide by negative 2. And we'll see if it's still true. So negative 12 divided by negative 2 is what? 6. Negative 8 divided by negative 2? Positive 4. Is that a true inequality?
No.
Okay, so we ran into trouble. I think I'll highlight. There and there was trouble. What's going on back here? Are we good? Okay. Huh? So don't miss this. This is going to be something you have to keep an eye out for from here on. In order to make this statement true, we have to flip that inequality around. Same thing here. To make this true, we have to flip the inequality. So when do you do that? I want you to pause for a second, just quietly think, and then I'll have you tell somebody. So I'm going to give you 10 seconds, maybe 15. Change the inequality symbol when fill in the blank. Just quietly think. Okay, put it into words to somebody else now. Give you another 20 seconds or so. Change the inequality when. Can you tell Levi? Levi, she's going to talk to you. And then Hudson, tell you guys, and Lucas talk. Abby, why don't you turn around and hear Gabriel. Declan, tell Jeremiah. Caleb, you tell me.
Oh, you would flip it.
I know, when? That's the question.
When it is unequal, when it is unequal and you have both numbers.
We're talking about operations as we go through. Oh, I'm solving, and now I have charge.
Oh.
Because I want you to think about it. You don't have those numbers. If you have one of them as an X, when are you going to flip that sucker around?
When you realize that it's unequal.
You won't know that because it'll say X.
Put it on the line and then we'll find out.
Tune in. We'll get you there. All right, everybody, listen up. Lucas, what'd you guys say? Okay. What'd you and Eliana say?
I'm not 110% sure. I'm pretty sure it's when you switch around.
You two guys, can you stop talking and listen? Exactly.
So you switch around the equation. Think that.
Well,
Like.
I'm asking again, so when do we need to flip the inequality symbol? What did we do to make the problem come up, right? Let's go back through and check.
Okay.
So if we add a positive, it was fine. If we subtract, it was fine. If we add -4, it was fine. Subtract 10, like anything making these numbers negative was fine. We divided by a positive, it was fine. Right here is where we first ran into trouble. What did we do? We multiplied by a negative. Okay? And then we also saw that if we do what here? Divide by a negative, it also caused it to be false. So if we're solving with x's or d's or whatever variable, we won't know it's false. Here's what I mean. Like if I have this inequality and it says x is less than -8, and I say divided by, let's stick with what we wrote. If I say times -3, you don't know what x is, so you can't tell me if this is false or not. You see what I'm saying? So we know what the actual value is. So can you say it now? If we blank and blank, we need to flip the inequality. If we multiply by a negative or
Divide.
yes, sweet. Good job. Good. Grab your notes. Let's go put that discovery on here. We're going to go put an example in your notes, but let me change the color. And after this, I'm going to give you a chance to do some work for a bit. We'll put something in the box, but go ahead and get caught up. Okay. So we're going to say solve the same as an equation. Except if you divide or multiply. Now, this is an important word. Even though it's 2 letters, it matters a whole lot. So I want you to underline the heck out of that thing. If you divide or multiply by a negative, flip the inequality. If you're dividing a negative, that does not what we just wrote. That doesn't matter. If it's by a negative, flip the inequality. Okay? And then this is kind of a follow-up, maybe just to make this clear. Then give your answer in the 3 forms above. Okay? So solve just like an equation, except this little twist, which doesn't always happen. Don't make it happen every time. Only if you divide or multiply by a negative, we will flip the inequality. So when you're done, go ahead and head back to the example section. We'll put some examples in there. Once we write this, we'll try to be fast. Once we write these, work time for you guys. Alright, I don't know where you guys are in your boxes. This is down here for me. Alright, I'm just kind of looking at where we're headed with these. Okay. We'll do one of each kind and then call it good, I think. Go ahead and write that one down. Again, we're going to put another one on the other side in just a moment. If this was an equation, do you feel like you could solve it?
Yes.
Cool. Based on what I saw on the test, yeah, I agree. Most of you very well could. Can, not could. What's a good first step? Yeah, I heard distribute. Let's get rid of these parentheses. Okay, what else? Or what next? Yeah, we do have these two little terms, the 6 and the negative 10. That would be good to combine. So 12x minus 4. So far we have done nothing different at all than solving an equation. What would you do next?
Divide x minus 12. Yeah. Minus 5x.
Okay. Subtract 5x. We'll get 7x and negative 7. Okay, what's next?
Add 4 and 7.
So remember, we're just working to get rid of things so that our variable stays by itself. This step was, I don't want variables on two sides, so let's get rid of them on one side and then keep it there. So Jeremiah is saying let's add 4. That undoes or gets rid of negative 4. And we're getting pretty close to 7, or I mean to x being by itself. 7x greater than or equal to negative 3. Looking good. Okay. To get x by itself, what's the last step? Yeah, divide by 7. And so x. Do we need to flip?
No.
Did we divide or multiply by a negative? No. If this 3 is negative, who cares? That's not what we wrote. We said by a negative. So this is fine just the way it is. Okay? And we don't need to turn this into a decimal. It's okay the way it is as a fraction as well. But let's go ahead and do the graph. We'll do it in 3 forms. That's the first form. I'm going to fix that 3 first. So that's form 1, and then we need to do the graph and the interval as well. So the graph, negative 3/7 goes on there, and then tell me about open circle, closed circle, left, right.
Closed circle.
Closed circle
Right.
to the right. It says greater than. Okay? Interval would be, maybe I'll write it over here. Okay? You guys, you're welcome to do these in any order. Like, do the graph and then the interval, or interval and graph, whichever is best. But is this going to be bracket or parenthesis?
Bracket.
Yeah, so bracket negative 3/7, comma to what? Infinity, parenthesis. Sweet. Alright, let's do one other one. This will be a more simple example. Okay, what should we do? Distribute first. You could divide by your -3 right now. I don't think I would do it that way myself. Okay, so we distributed. Be careful with sign. We get -3x, and then negative times negative is positive 15. Now what? Yeah, let's work to get x by itself. So far, nothing we've done has been detrimental to our inequality. It's all normal. But what are we doing here? We're about to divide by a negative. Okay? So, caution. Divide by, there's that word, by a negative. So what do we need to do? Yeah, we need to flip that guy around. And we'll get x and 5/3. So flip the sign. We need to finish writing that. So flip the inequality.
So if you do it again, does it get reversed?
Yeah, good question. So Declan is asking, what if we had buried in here another operation where maybe this x was still negative and we had to divide again? Flip it back. Every time you divide or multiply by a negative, you have to flip-flop the thing. There are problems where you might have to do it 2 or 3 times to the end. So just pay real close attention to each step. Yeah, thanks for asking that. That's awesome. Alright, that's the first form. Second form is another form. There's not a really particular order for this. Closed circle pointing left, and then our interval would be negative infinity to 5/3 bracket. Okay.